for switching class periods.
All right, here we go. Hopeful Spencer and Jeb would like to give you a shout out today because they are both in the same class period. God bless my heart. All right, so number 1, in which of the following systems would the number of moles of substance present at equilibrium not be shifted by a change in the volume of the system at constant temperature? And you should have gotten D. You should have gotten D. Now, changing the volume is going to affect what? We don't care that they're changing the volume. We care that changing the volume is going to change the pressure?
Right.
Pressure. Okay, pressure. Volume and pressure are inversely related. Remember that? Okay, if I increase the volume, what happens to my pressure? Decreases. If I decrease my volume, what happens to my pressure? Increases. So, if I change the volume, the only way it affects my problems is if I have a what on each side? Different number of moles of gas. And so D is the only one where I have the same number of moles of gas, so the answer is D. We see that? We see that. Okay, go for it. Yes.
If one of them were a solid ND, and it was just like 1 mole on one side and 2 on the other, like would that,
The solid doesn't count.
like what I'm saying though is like if one of them
Like
was
if this was a solid,
yeah, and
then this would be affected.
okay,
Yes.
I was just wondering.
Yeah. Okay, good question. All right, number 2, the solubility of CuI is 2 times 10 to the negative 6 molar. What is the solubility product constant? Sorry, I didn't change the slide, did I? There we go. What is the solubility product constant, KSP, for CuI? Now remember, anytime they give you solubility, what they did was they gave you X. Okay, so this is KSP, solubility product constant. So I know CuI was a what? Solid. So that was a solid. It dissociated into Cu positive plus I negative, right? I don't care about this one. They initially started at 0. I add X, I'm at X and X. Okay? So that means KSP is going to be equal to X squared. Correct? Yes? So they gave me X. So this is 2 times 10 to the negative 6 squared. 2 squared is what? 4. So that automatically should have taken out all of the answer choices except C.
Oh, we square rooted it.
Good try.
Everybody see that?
A for effort.
Yes? And if I do negative 6 squared, that means I need to do negative 6 times 2, which is negative 12.
We got one more.
Do we all see that? Yes. Okay. All right. Let's go to number 3. Excuse me.
Number 1 was D.
All right. Hey. Hey, hey. Thank you. Goodness. It's okay if we missed one.
We missed like
I had D in Jodio's. Number 1 is B. So
I said that's what Ashton put.
You did not say that.
All
I
right.
said that's what Ashton put.
Excuse me. All right. Let's talk about this. All right. When 0.4 moles, I'm going to write this over here, by the way, so I can do this with you.
Could they like send it like you were now?
Yeah. That's all we can see. We can't see. All right. When 0.4 moles of SO2 and 0.6 moles of O2 are placed in an evacuated 1 liter flask, that means I can get molarity, right? Because for my rice table, I need molarity. So 0.4 and 0.6 divided by 1 would just be 0.4 and 0.6, right? So I know I'm starting out with 0.4 molar of this, and I'm starting out with 0.6 molar of that, correct? They don't give me any product, so I'm assuming I'm starting with 0 there, okay? And so then I'm going to subtract 2x, subtract x, add 2x. Everybody with me? Yes? All right. After the reactants and the product reach equilibrium and the initial temperature is restored, the flask is found to contain 0.3 moles of SO3. Based on these results, the expression for the equilibrium constant Kc of the reaction is. So I get to 0.30 molar there. So x is equal to what? 0.15. So if I subtract that, that gives me 0.10 molar, and that would give me 0.45 molar. So therefore, the correct answer to this question is
We put that, but we just looked at the equation.
Hey, we tried.
Does everybody see that?
Y'all.
Okay. Why did I square the 0.3?
That's two in front of it.
Because it has a 2 in front of it. Same thing for the SO2. Questions on this, or do we understand it?
So it gives you an exact.
No, this is just a rice table. That's all this is. That's why they gave me the 1 liter, because I changed these moles into molarity and set it up as a rice table. Okay. All right. Number 4. At a certain temperature, the value of the equilibrium constant K for the reaction represented above is 2.0 times 10 to the 5th. What is the value of K for the reverse reaction at the same temperature? What do I do to K if I reverse it?
Put an H on it.
I take the reciprocal. Okay.
That's first.
All right. Remember, that's what you do with H. You're on H. That's cool. At least you know that one. Okay, that's H. All right. Remember, we'll review K right quick. When we remember with delta H, when we flip it, we just make it negative. With E naught, when we flip it, we make it negative. Everybody remember that? Okay. And when we combine delta H equations, we just add them all up. You're still with me there? All right, remember with K, the rules change, okay? When we have to add the K's from other equations, that means we multiply them. We would do K1 times K2, okay? When we reverse or flip an equation with K, that means we take the reciprocal of K, okay? And if we multiply through by 2, 3, etc., then that means we take K and we raise it to whatever we multiplied it by. Everybody remember that? So we're back to that. Okay, so since we did the reverse reaction, we would do the reciprocal of 2.0 times 10 to the 5th. So 1 divided by 2 is what? 0.5. And then since I put this at the bottom, that 10 becomes 10 to the negative 5th, right? Yes. So then I would change that to 5 times 10 to the negative 6, which would be B.
You can make some of
Yeah?
No?
Yeah. Okay.
I should have.
All right. By the way, so you can take these home and study, why don't you write on what you have right now, and I'll just make copies for my next class.
Try this.
Yes. Do y'all want to do that? Just write on the sheet that you have, and I'll make extra copies for my next class. That way you can keep that. And if you're not going to write on it because you know you're not going to study it, that's fine. Just turn it back in to me. Gotcha, Will. Gotcha, Will. All right.
3 4 was.
So 1 was D, 2 was C, 3 was A, 4 was B. So D, C, A, B. Okay?
Man, this is bad. Can you like spell his X?
All right. Number 5. What is the molar solubility in water of silver chromate? The KSP for silver chromate is 8 times 10 to the negative 12. Okay? So they're asking me for solubility, so that means they're asking me to solve for what? X. Right? So they're asking me for X. So I say, well, Ag2CrO4 I know is a solid. How do I know it's a solid? Because they told me this is KSP, right? So this is going to dissociate into Ag2 Ag positive plus CrO4 2 negative. Okay? So I would start, this one doesn't count because it's a solid, 0, 0 plus 2x plus x, 2x and x, right? And you don't have to write this out, obviously, on the multiple choice exam if you can see it. But some people can't see it, so they need to write it. That's totally up to you, okay? So that means KSP would be equal to the concentration of Ag positive squared times the concentration of CrO4 2 negative. Yes? Yes. So KSP, and so this would be equal to 2x squared times x. I just filled in my equilibrium values. So 8 times 10 to the negative 12 is equal to 4x cubed. Does everyone see that? Okay. All right. So to find the value of x, I'm going to divide by 4. 8 divided by 4 is 2. So that's 2 times 10 to the negative 12 is equal to x cubed. So then to solve for x, I would have to do what? Take the cubed root. So the correct answer is D.
Yeah, we got that right.
Hey.
There you go.
Good job.
All right. Yes?
Yeah.
Yes.
Yeah.
Again, I'm going to stress, if we didn't get it before, are we getting it now?
Yes.
Okay? All right. Good. Jeb, I'm so glad you're getting it.
I am with it.
It's an encouragement. All right, here we go. The chemical equation for the formation of hydrogen chloride gas from its elements is shown above. Given that the equilibrium constant for the reaction above is Kp, which of the following best represents the equilibrium constant for the expression HCl goes to 1/2 H2 plus 1/2 Cl2? All right, what did we do to this equation? We reversed it and halved it. So when we reversed it, we had to take the reciprocal, and when we halved it, that means we had to raise it to the 1/2 power, which is the exact same thing as doing what? Taking the square root. So therefore the answer is C.
I learned.
Okay.
Good job, Noah. You're on a roll.
All right. 7. 7. If the acid dissociation constant Ka for an acid HA is 8 times 10 to the negative 4th at 25 degrees Celsius, what percent of the acid is dissociated in a 0.5 molar solution of HA at 25 degrees Celsius? Okay. So, we're taking HA and we're dissociating it into H positive and A negative, right? HA just means it's an acid, okay? And we call it HA because acids normally have what in front of them? A hydrogen, right? So this is just the hydrogen ion and its conjugate, okay? It's conjugate ion. So there we go. So HA goes to H positive plus A negative. I start with a 0.50 molar solution. So I'm going to be 0 and 0, subtract x, add x, 0.50 minus x, and x. At this point in your career, you should be able to knock out a rice table very, very quickly without really thinking about it too much. Okay? You should be able to handle this. So that means Ka, all right, is going to equal to x squared over 0.50 minus x, and I'm going to neglect that x, right? Exactly what I'm going to do. All right, my value of Ka they gave me was 8 times 10 to the negative 4th. Okay, so the first thing I'm going to do is cross multiply, right? Right? So 0.5 times 8 would be 4. So 4 times 10 to the negative 4th is equal to x squared. So now I'm going to take the square root. So the square root of 4 is 2. And if I do the square root of 10 to the negative 4th, I should get 10 to the negative 2. Right? If I take the square root of an exponent, by the way, just half it, in case you didn't already know, is equal to x. Okay, so that's what x is equal to. It didn't ask me for x, though. It asked me for how much of it dissociated. Okay? So what is the percent dissociation? So your equation for percent dissociation, in case you have forgotten your equation for percent dissociation, okay, is the amount that dissociated, which would be x, okay, divided by the initial concentration times 100. So I take my value for x, which is 2 times 10 to the negative 12. I divide that by my initial concentration of 0.5, and I multiply that by 100. Okay, I'm sorry, that's 10 times 10 to the negative 2. I don't know why I put 12 there. I'm stuck on the next problem. Okay, so 2 divided by 0.5 would give me what?
0.004.
It would give me 4 times 10 to the negative 2. Multiply that times 100, and you should get 4%.
We were so close. Secret chemistry didn't come through for us.
All right.
Seven.
Yes? Yes.
Good try there.
Huh?
Did you get some?
Oh, yes, I can go back. Sorry. My bad. Okay.
You did it on purpose just to look good.
All right. In the equilibrium represented above, the species that act as bases include which of the following? H2O
You have to put the positive by two.
and SO4 negative.
That's okay, guys. We tried.
A conjugate base is a base, okay? And think about it like this. Notice, what do we have here? Okay? We've got that arrow that indicates that the reaction is reversible. So not only can it go forward, but it can also go backwards. Okay? So acids donate, bases accept. Okay?
Good job, Laura.
All right. Number 9. What volume of 0.5 molar HCl is required to neutralize 25 milliliters of 0.12 molar barium hydroxide? Okay. So what equation do I need for this one? There you go. M1V1 is equal to M2V2. So I've got 0.150 molar of my acid. I don't know what volume I need. I have 0.12 molar of the barium hydroxide, and I know I've got 25 milliliters of it. Okay? So I'm solving for X. Remember, I can't use a calculator. So I've got to find a good way to get this solved, and multiplying 0.12 times 25 in my head does not seem like a good way to do it to me. Okay? Does not at all. So if I divide this by 0.150, we should notice something. Can I do 12 divided by 15 and make that a fraction easily? What does 12 over 15 simplify to? 4/5. So I've got 4 over 5 times 25 now. What's 4 times 25? 100. What's 100 divided by 5? 20. Okay. Remember, on multiple choice, they know you can't use a calculator. So they specifically use numbers that are easy to manipulate. Remember that. Okay? So if you're doing something that is impossible to do in your head to a normal average person, okay? Or let me rephrase that. For a normal average AP chemistry student, all right? Then you're probably doing it wrong. Okay? There is some way in there they have it so you can manipulate it. Yes, sir.
Can we make it so can we like convert to like 15 instead of 1.15 or with that?
Yeah, you could. As long as you convert both of them. Yeah. Okay. All right. What is the H positive concentration in 0.05 molar HCN? The Ka for HCN is 5.0 times 10 to the negative 10. If you have not figured this out by now, I need you to figure this out. If they give me a big K, I'm setting up a rice table, period. Okay? That is what I'm doing. So I've got HCN. It's going to dissociate into H positive and Cn negative. I'm starting with 0.05 of it. 0, 0, minus X plus X plus X. 0.05 minus X, X, and X. And it should be just that simple for you. Okay? So I set up my expression. My Ka is 5.0 times 10 to the negative 10th is equal to X squared over 0.05 minus X. And of course, I'm going to neglect that X. So I'm going to cross multiply first. 5 times 5 is what? 25. How many decimal places are here? 2. So I'm going to make that 0.25. Why did I not count this decimal place there? Because really I could just as easily say just 5, right? So it doesn't count. All right. So 0.25 times 10 to the negative 10th is equal to x squared. Okay. So now I'm going to take the square root. Okay. The square root of 0.25 is going to be 0.5. No, just 0.5. Okay. Because look, 0.5 times 0.5, what's 5 times 5? 25. How many decimal places? 2. 1, 2. Okay. So 0.5 times 10 to the what? Negative 5th is equal to x, which would give me my concentration of hydrogen. So of course I'm going to have to change this. If I make this number bigger, I've got to make this number smaller. So that's 5 times 10 to the negative 6th. Okay. You good?
She worked it out in the board.
All right.
What?
All right, mixtures that would be considered buffers include which of the following? What am I looking for a buffer?
Weak acid and conjugates.
Okay, a weak acid or a weak base and its conjugate salt. Okay, so remember, a salt just means it's what kind of bond? Ionic. Okay, that's all we're talking about. It's just an ionic bond. Okay, so you should have automatically said, well, strong acid, strong acid, strong acid. That's the only one that's a weak acid, so therefore it's the only one that qualifies. Okay. All right. That's literally all you had to do there. Okay. All right. You're going to be fine. All right. Number 12. Excuse me. Which of the following aqueous solutions containing 1-to-1 mole ratios of the following pairs of substances at 1 molar concentrations will have the lowest pH? Lowest pH means I'm looking for what?
The most basic. No, the most acidic.
The most acidic. So which one of these is going to give me the most acidic?
See, if we were thinking right, we would have had 11 and 12. Like, we just thought opposite.
It's okay.
Did we get 13?
You'll be all right. You will. All right, 13. Which of the following is the conjugate acid of NH2 negative?
See?
B?
D.
Please tell us this is B.
It's B.
You know what? Never mind. I'll take my loss off here. I forgot to write down 13.
You can give it to her for group. If her group put it, she's good.
Appreciate that.
Okay.
Wait. It's not really involved much.
All right.
Okay, so it's B because it accepts a hydrogen. Is that why?
Because remember, bases accept the hydrogen and they become the conjugate acid. Okay? So if this is my acid, I'm going to accept a hydrogen and become the
I
conjugate
feel like that was
acid.
a trick question because I'm marking NH4
Okay.
positive because it's an acid.
Got you. And NH3 is a base. You are correct about that. All right. Let's move on to 14. Y'all are cracking me up today. Cracking me up. All right.
I'm not giving up hope for
Look.
class.
So you won't miss it Monday. Now we're refreshed and we're good to go for Monday.
Where was I?
Okay?
What time do we need to be here? Where do we go
Fine.
for that? Yeah, where are we going?
All right. We'll talk about that in just a second. Let's finish.
I think we're about to.
Yes.
We got here 9:30.
Next 2 hours.
12 minutes.
All right. Here we go. Let's get through this really quickly. I'm just going to go through it and show you where you should get the points. So just pay attention and hold on for the ride, okay? So we can get through this before class is over. We'll just completely eliminate 15, Okay, you can take it home and try it, and you can send me pictures if you want to see if you got it right, but we're not going to go over it in class. All right, A says write the equilibrium constant expression for the dissolving of silver chromate. And so for A, you should have said Ag2CrO4 solid would go to 2Ag positive plus CrO42 negative plus 1. Okay.
It was the equilibrium constant.
Oh, sorry. I wrote
I was gonna say, I know I'm not that
My bad. I wrote the equation over again. So you should have said KSP is equal to the concentration of Ag positive squared times the concentration of CrO42 negative plus 1. My bad, y'all. I'm in my own little world right now.
Hey, good stuff. No.
All right. B says calculate the concentration of Ag positive in a saturated solution of silver chromate at 25 degrees Celsius. So that means I've got to set up a rice table. So here we go. So Ag2CrO4 goes to 2Ag positive plus CrO42 negative. I don't care about this one because it is a solid. 0 and 0 is what we would start with. We're going to add, well, if my smartboard comes back on. All right. We're going to add 2x, add x. It's thinking about it. There we go. And so I would be at 2x and x. So then I would say, well, I just figured out my KSP. And they gave me my KSP value. So I would say 2.6 times 10 to the negative 12 is equal to 2x squared times x. So that means this is equal to 4x cubed, because 2x squared would be 4x squared times x, which would be 4x cubed. So then I'm going to divide by 4. And I'm going to take the cube root to get x, which means x is going to be equal to 8.7 times 10 to the negative 5th molar. But since my value at equilibrium for silver should be 2x, I would multiply that by 2 and say my concentration of Ag positive is going to be 1.7 times 10 to the negative 4 molar.
Wow. What are we going to put?
Okay? So,
Hey, what if they have 1.09? Is that close enough? Yeah. Times 10 to the negative 4.
That's close.
1.09? No,
So,
1.1 is not
oh.
close to
Just mark
1.7.
out the O. Just do
Okay?
it.
All right. Here we go. So, you got 1 point if you set it up correct with the stoichiometry, meaning you have 2x squared times x. Okay? So if somewhere on there they had that set up right, they get a point, and then they get a point for having the correct concentration of silver. Okay? All right. C says calculate the maximum mass in grams of silver chromate that can dissolve in 100 milliliters of water. So I know what my solubility is because I found x, right? And x is equal to the solubility. Okay? So I say, well, 8.7 times 10 to the negative 5th moles per 1 liter can dissolve, right? Because that's molarity. Remember, in my equilibrium tables, all of these are molarities. Make sure you remember to put your units. Okay? So that's how many moles I can dissolve per liter. I want to get moles to what? Cancel. So I'm going to say, well, in 1 mole of silver chromate, I have 331.7 grams of silver chromate. So that gets me to how many grams per liter. But they asked me how much can dissolve in 0.1 liters. So now I need to get, they just asked me for grams, so I need to get my liters to do what? Cancel. So I'm going to multiply this by 0.100 liters, and that will make my liters do what? Cancel. And now I'm just left with grams. And if I did all of that, then I would get 0.0029 grams. Okay? You get a point for the answer, and you get a point if you found the molar mass and knew you had to multiply by it somewhere in there.
Do we still get points though if we solved correctly using the wrong numbers?
Yes.
Ooh.
Yes.
So you don't get any points for just getting the correct amounts.
I like it.
She
That
just
means
said,
you need to check
Yes.
yourself.
if you found all those.
Check yourself before you look at yourself.
What?
Yes. You get a point just for having the correct molar mass. And you get a point for the answer. Now, if you had the wrong molar mass, but you set it up correctly and got an answer, then you get a point for the answer, but no point for the molar mass.
But what if they set it up correctly through a completely random answer? So we're not going to check it.
They would check it, though.
So we're going to give them a point anyway?
Yes.
So
We're just going to be generous today. Okay. All right. Excuse me. D says, if we add a sample of silver nitrate to the solution, is the concentration of CrO4 going to increase, decrease, or remain the same? And please justify your answer. Okay? Now, all I care about when I add the silver nitrate, remember my solubility rule says anything bonded to nitrate is completely what? Completely soluble. Okay? So that means really, I'm just concerned, that means I'm adding in what? Ag positive, right? That's what I'm adding in. So when I add in Ag positive, what happens to Q?
It becomes greater than K.
It becomes greater than K. Yes? Do we see that? I added in product. Here's my expression. This goes up, so Q becomes greater than K. Okay? So we can write this as Q becomes greater than K, or we could write that as K is less than Q. Why do I write K first?
It shows you which direction.
Shows me which direction it's going to go. So because Q became greater than K, what's going to happen to this reaction? It's going to shift left. And why is it going to shift left?
You added bugs.
Because I added product. So it's going to shift left to reestablish equilibrium.
As long as they have something about Q being greater than K, it's just a
Yes. Okay? So it's going to shift left to reestablish equilibrium. So my concentration of CrO42 negative is going to what? Decrease. All right. So that would be 1 point as long as they said it's going to decrease and they justified it using Q and K.
You have to use Q.
They are really big on it now on the AP exam, yes. Okay. Anytime they ask you anything like that, justify it using Q. Okay. They won't accept basic Le Chatelier's principle anymore. Like I added product, so it shifted. For some reason, they're not okay with that anymore. I agree. All right, we're almost done. Hold tight. E asks you to write a balanced equation for this up here. So Ag3PO4 solid goes to 3 Ag positive plus PO4 3 negative. That's plus 1. Then they asked me to calculate the value of KSP after they gave me the concentration of silver, right? Right. So I already know that the KSP is going to be equal to the concentration of silver cubed times the concentration of PO4 3 negative. Okay? I have the concentration of silver already. They gave that to me, 5.3 times 10 to the negative fifth. And I'm going to cube that. I need the concentration of PO4. How am I going to get the concentration of PO4?
Why do you have to keep that? Like, why is it?
Because I've got 3 of them there.
I just assumed that it was like a total overall like that or to keep that.
They have it. Okay. What do I have to do to find my concentration of PO4 3 negative?
Divide by 3.
Divide by 3, right? Because if I would have set up a rice table, this would have became 3x and this would have became x, right? So I divide by 3. So, and you would need to show that, by the way, on your paper, somewhere where you divided by 3 to get CrO42 negative. Okay? So I divide by 3, and that will give me 1.8 times 10 to the negative fifth. And so then if I work that out, then I get 2.6 times 10 to the negative 18th for my KSP. So plus 1 for the KSP, plus 1 if you set up your KSP expression correctly. All right, and then G asks you, what's the concentration of silver in the final solution if I evaporate the final volume to 500 milliliters? The concentration of silver is the same because it is independent of volume. And we're not going to count G, so don't worry about it. All right.
Like those points they got and like those